Hey everybody, it's David Townsend from the Net Academy. Welcome to this video where I'm going to be going through the OSPF or Open Shortest Path First virtual links. We're going to go through what are virtual links, why are they needed, and ever so slightly why you should not keep virtual links as a permanent solution on any OSPF network. I'll go through the slight details into that. It won't spend a lot of time on that particular subject, but of course we're going to be spending time on how to configure a virtual link between two different OSPF areas on the Juniper Junos devices. So let's get going onto this lab to learn all about the virtual links itself. And here is the lab that we're going to be using for this video. As you can see, it's not a complicated or wide big network. We don't need it to be, because all we need to know is how to configure virtual links on OSPF speaking routers on the Juniper Junos devices, but also what are the virtual links, so we don't need a huge scaled network. But first, what is the virtual links? The best way to describe what a virtual link is to really describe what we are actually looking at, what we are seeing here. And what we are seeing here are two different companies. We've got company X and company Y. I'm very imaginative, there we go for the names. But as we can see on company X, they've got area 0. We can also see for company X, they've got an additional area, area 1. Now to keep it straightforward and simple, in area 0, they've only got this one router, R1. And then we've got this ABR, this area border router, that is R2, which is an ABR between area 0 and area 1. And in area 1 we've of course got R2, R3 and R4. In company Y, a lot more straightforward, they've got area 0, and in here they've only got two OSPF speaking routers. We've got R5 and we've got R6. Now what happens when a company acquires another company? As we all know and have probably experienced in our lifetime, in our professional work in life, there's a lot of things that actually happen, both from a legal point of view, from a human resources point of view, and from a networking point of view. And this isn't always the case when you need virtual links, but in such a scenario, what could happen is when company X acquires company Y, they need to merge their networks. They need to bring the network infrastructure into one domain, ideally. But in such a scenario, they've got different networks to begin with. Obviously, they're going to migrate together towards the end. That would be the end goal. But as we can see here, company X have got their area 0 here. Company Y have got their area 0 here. And right in the middle is just this free space. That could be the internet, MPLS connections, whatever it is. Now, as we know in the OSPF protocol, we need a contiguous area. You cannot have a discontiguous area, so you cannot have one area 0 over here and another area 0 over here. It's just going to break the OSPF protocol. The area 0 needs to be a single area, and additionally you can't have area 0 here, area 1 here, and say area 2 connected to area 1, which will then go onto area 0. That's not allowed. It's not the hierarchy of OSPF. OSPF requires area 0 to be that backbone, that transit network, and all non-backbone areas such as area 1, 2, 3, etc., etc., to be connected to area 0. You cannot have a non-backbone area connected to another backbone area connected to the backbone area, area 0. It's just not allowed. That's where virtual links come in. What they allow is they allow the OSPF speaking routers to create a virtual link to each other, to and from each other, and thus you can bond as such. You can form those adjacencies, those connections from one area to another area into that backbone area in this case. Now in this specific scenario, when company X has acquired company Y, they need area 0 to be complete. They need area 0 to be intact. That's the OSPF hierarchy. A transit area is a transit area. Now, what would happen in such a case is, in the ideal world, we know this isn't always going to be the case, is that company X would pay for that cabling, that fiber optics, that connectivity to go from R1 ideally all the way over to R6, maybe over to R5 as well. But that's going to cost a lot of money. It's going to take a lot of time. And in such a migration from migrating company Y into company X, you know, they might not be willing to spend that money. We all know that can be the truth, but also the time it can take. So as a quick fix, you can use the OSPF virtual link to bring area 0 through area 1 and into area 0 here. However, it is not a permanent fix. It is a temporary fix. And there's no technical reasons as to why it shouldn't be permanent. The real reason behind it is that it just breaks the OSPF hierarchy. It breaks the design. It creates a discontiguous network. And it's also bad design. So if this was area 2 over here and not area 0, this would really be a bad network design. And that's why I'm using the scenario of company X acquiring company Y, because in reality this happens, and I'm sure it has happened, and one company acquired another company. Both have OSPF speaking routers or speaking routing protocols, and they need to migrate them together, and as such their area zeros, their backbones, are discontiguous. They're not single. Now, as we know here, you're going to have probably BGP and all the rest of it. It really doesn't matter for this scenario. So what would happen in such a scenario, let me just disable my screen brush, is we would extend area 1, if I get the drawing box here, we would extend area 1 to, as such, come all the way over here. So let's also go through why you should not keep a virtual link as a permanent solution. Well, in the OSPF protocol, as I said, you cannot have two different area zeros. It's got to be one big transit area. And if we look at those good old LSAs that are exchanged between OSPF speaking routers, as we know, as we've seen on other videos, and in the description box, all the other videos I've done on OSPF, check them out. In a single area between routers, these are going to be exchanging those type 1s, those type 2s back and forth. The type 1s being the router LSAs describing what each router has connected to itself, the interfaces, the network IDs, the subnet masks, the cost, the route ID, and a lot more. And the type 2s is really that network LSA for saying who is the designated router, the ID, etc., and what are the networks in this single area. Now, when those type 1s and type 2s come to the ABR, that in this case is R5 and also R2, the ABRs are translating, are summarizing those type 1s and type 2s into a type 3. So all those type 1s and type 2s come from R6 onto R5, and R5 translates or summarizes those type 1s and type 2s from area 0 into area 1 as a type 3. Now, as those type 3s go through area 1 in whichever direction, but as those type 3s come through area 1 and hit R2, another ABR between area 1 and area 0 is not then going to take that type 3 LSA and inject it as another type 3 LSA back into area 0, because it's going to be like, well, hang on, area 0 is over here, but now it's over here as well. What's going on? So it does work, but it's not a permanent solution. I want to reiterate that it's not a permanent solution. It's a temporary solution for situations such as we've gone through, one company acquiring another company. And so area 1 has been extended from company X into company Y, specifically extending from R3 and R4 all the way across to R5. But where is that virtual link actually built from? Well, it's actually built from the ABRs themselves, because the ABRs have, in this scenario, have an interface between area 0 and area 1. And so we're going to build a tunnel which tunnels, or a virtual link which will build the link from R5 across to R2, and it's a two-way street. We also then have to build that virtual link from R2 over to R5. And it's very simple. We're basically defining on R5 and R2 what is that transit area and what is the neighbor ID. So in area 0 on router R5, we're going to say area 0 virtual link through the area 1, the transit area, and I want to get to router ID 2.2.2.2 or 1.1.1.1. So let's go on to the lab and let's actually start configuring this. And here's the secure RT, here's the COI into the lab. Now on R1, if I actually do a show OSPF neighbor, we can see that it's got the adjacency to R2. If I do the show OSPF database, we can see that you can see the network between R2 and R3 and R2 and R4. It doesn't, however, see the network between R3 and R4 to R5 because we haven't built that yet. So if I go on to R2 and do a show protocols, show configuration I should say, protocols OSPF, then we can actually see what's been configured on OSPF in the running mode, not the configuration mode. So we could see it's on R2, we've got the one interface pointing to area 0, and we've got the two interfaces pointing to area 1, to R3 and R4. Do we have adjacency? So let's do a ping 200.10.20.10. So that is R4's interface, and we have connectivity there. Do we have connectivity to R5's interface, the GIG E003? So that's 200.10.20.14, and we do not, because we do not have the root. We've not configured an R3 and R4 and even R5 that configuration for OSPF. And just to back that up, if I do show configuration protocols OSPF, we can see that it's just got on R3, and it's the same on R4 and R5. It's only got the relevant interfaces for area 1. It doesn't have on R3 the GIG E005 interface, and that's what we need to change. So let's do configure mode and let's do set protocols OSPF area 1, and I need to point this out of the GIG E005 interface. Really, not 25, that will not work. And let's do a commit and quit, and I need to do the same on router R4. So it's going to configure mode, let's do edit protocols OSPF, do a quick show so you can see what's configured, and let's now change this to set area 1 interface GIG E005.0, do show again, commit and quit, and we now need to go over to R5 and point out those same interfaces. So let's go to configure mode, do edit protocols OSPF, show set area 1 interface GIG E0, and we need the GIG E3 interface, and we also need the GIG 4 interface. Let's do show again, and let's do the commit and quit. And once that's committed, what we should then have is area 1 extended from company X between R3 and R4 over to company Y on the R5 GIG interfaces. So let's actually test connectivity now. So on R3, can we ping R5? So let's do ping 200.10.20, and it is the .14 interface. And we now have connectivity. How about on the R4 interface? So let's do a ping 200.10.20, and that is the .18 interface, and we do have connectivity. And now if I do the show OSPF database, we can now see everything on R5 because we've got the router LSA here. So if I do the show OSPF database router LSA, and I want to look at the LSA ID of 5.5.5.5, so 5.5.5.5, and let's go to the detail. We could see all the networks, the subnet mask and the cluster, so I was saying that is connected to R5. But let's come back to that virtual link. Does R1 and R6 see each other yet? No, because we haven't created that virtual link between R2 and R5 and vice versa. As I said, it's a two-way street. And to back that up, let's just do that show OSPF database, and as you can see, we are not seeing R6 here. And to illustrate that, if I actually try the ping 200.10.20.22, which is R6's GIG interface here, and you can see it's got no host. So even though R5 knows of R6 and R3 can see in the link state database, yet you've got all these networks attached to you, because we do not have this virtual link connected between the two ABRs to go from area 0 to area 0 through that transit area of area 1, this simply doesn't work. And so let's now create that virtual link which will allow, hopefully it will happen, R1 to ping R6 through that transit area of R1. So I'm on R2 because this is the ABR. So let's go into that configure mode and let's do edit protocols OSPF. Do a quick show so we could just see what it looks like before we actually push this configuration. So I need to configure in area 0 that transit area into area 1. I can't configure that transit area in area 1 for the transit area of area 0 because then that would be going the other way. So we need to do set area 0 virtual link. And if I give a question mark here, we now have two simple commands. What is the neighbor ID? Now that is the router ID. Because I'm on router R2 and I need to build this link to router R5, R5's router ID is 5.5.5.5. So this is where I want to build that virtual link to. So we need to create set area 0 virtual link neighbor ID 5.5.5.5. And now I need to say what that transit area actually is. So from area 0 I'm going to transit through area 1, and that's simply it. So if I now do show, we can now see I've configured that virtual link on area 0 to go through area 1 to R5. Let's do a commit and quit on R2. Now as I said, it's a two-way street, so I have to do the same on router R5. Let's do edit protocols OSPF, do a quick show, and let's do set area 0 virtual link neighbor ID, this time it's R2, so router ID of 2.2.2.2, and the transit area is area 1. Let's do a show again, and we can now see it has created that virtual link. Let's commit and quit. So with that configuration actually committed now on both R2 and R5, let's actually see from an OSPF perspective, is the virtual link up? Can we see that adjacency? And can actually one of these ABRs actually in different companies ping the other end? So let's go on to router R2. Very great command this. I love this. I love seeing this all working. Let's do a show OSPF interface. This is what I like. We can see here the virtual link, VL, virtual link to 5.5.5.5. It is point to point, and we have got that neighbor adjacency. Additionally, if I do a show OSPF neighbor, we can see that we have got that neighbor adjacency in that full state to R5 with that through that virtual link. I absolutely enjoy seeing that theory making practice. And if we do the same commands on R5, let's do a show OSPF interface, we could see exactly the same information. The virtual link is there, it is up, and the full adjacency is there. But can we get this end-to-end connectivity from these different companies? So let's do that ping 200.10.20.1, which is R1's Gigi 0002 interface. And we do have that connectivity, so R5 can ping R1. And there we go. That is a very short, quick video on how to configure virtual links in a Junos environment. As I said, these are not permanent configurations. They never should be. And it's really down to the LSAs, the summary LSAs being summarized from one area into another area. So as we saw, we had two discontiguous area zeros with that transit area, area 1, and as that type 3 LSA goes through area 1 from one area 0 into through area 1, it's not then going to be translated, summarized again into another area 0. It just breaks the hierarchy, whereas the virtual link can get around that. It's not perfect though, and again, it's a hierarchical design problem. OSPF needs all non-backbone areas connected to that backbone area, which is area 0. So I hope you found that useful. If you like what you saw, please subscribe to my channel, hit like, share, etc. I love your comments, I love your feedback. Keep it coming. Thanks for watching, and see you on the next video.